We are designing a semi-automated post-processing system for Borneo Apong Golden Syrup. Our goal is to boost its economic value while preserving its Sawakian cultural roots. By keeping a strict pH between 3.8 and 4.2 and water activity under 0.85, this affordable technology minimizes human contact, prevent contamination, and meet strict FDA and USDA food safety standards.
Borneo apple golden syrup is highly vulnerable to microbial contamination during packaging, compromising safety and shelf life. Existing methods lack the process control and inspection needed to prevent spoilage and recontamination. To address this, an effective post-treatment packaging system with continuous monitoring and reliable materials must be developed to eliminate pathogens, maintain quality, and boost efficiency. Objectives are to design an affordable, practical, semi-automated post-processing system for small-scale production, to ensure consistent operational conditions to reliably eliminate targeted pathogens, to integrate such as seal quality control to prevent post-process recontamination, and to align the solution with UN Sustainable Development Goal 9.
For literature review, thermal vs non-thermal pasteurization technologies. Hot water pasteurization is a highly effective, budget-friendly thermal process that eliminates pathogens while preserving food, nutrition, and taste. Unlike complex, expensive non-thermal methods like high-pressure processing (HPP), a uniform water bath distributes heat evenly and protects sealed packet from harsh, direct heating elements. In terms of microbial contamination and process validation, raw gula apong syrups, low pH 5.6 and high moisture promote dangerous bacterial growth, such as E. coli and coliform. Because temperature readings alone cannot prove complete disinfection, rigorous quality control and sample processing are required to confirm pathogen elimination and validate the system safety standards.
Okay, moving on to the methodology, we consult the panel before improve our design, and we make some experiment and finding that the sunset sink instead of float. Next, we added more sensor, and then we finalize our 3D design into three main parts: the control panel, pasteurization tank, and drying box. And finally, we conduct an engineering analysis focusing on static load, variable loading, and power transmission. So this is our new improved design, and the right one is a control panel, and the middle one is water tank for pasteurization process, and the left one is for the dryer box to dry the sunjet. So this is the result after doing some calculation on static loading analysis. We found that the best material for this for our design is stainless steel 304 because the yield strength required is 210. Then the stainless steel 304 have higher yield strength which is 215.
For variable loading analysis, we found that the allowable stress is 84.848 megapascal and alternating stress is 6.50 megapascal. This will mean that the shaft will never fail due to the fatigue from cyclic loading. For bearing analysis, we found that the required dynamic load rating is 1.64 kilonewtons. So the selection of the bearing is the SKF 6200 deep groove ball bearing where the bore is 10 mm.
Final result of our power transmission analysis as illustrated in the slide. Looking at the conveyor metrics, our design tractive force is established at 14.72 Newton to overcome a friction tractive force of 5.89 Newton. To facilitate this, we decided to use a stainless steel food grade gear featuring a 2mm module, 25 teeth and a pitch circle diameter of exactly 50mm. In the term of power, our design driving torque is calculated at 0.368 Newton meter. This delivers a net transmission of 0.59 watts, necessitating a minimum power of 1.73 watts. Critically, the gear tube bending stress remained exceptionally safe at just 1.08 megapascal, ensuring high structural longevity. Finally, our belt tension analysis indicate that 9.64 Newton and on the tight side and 3.76 Newton on the slack side. We decided to use the food grade stainless steel for two simple reasons: strength and safety. While it is strong enough to handle our machine mechanical power, its biggest benefit is how clean it is. It has a smooth surface where bacteria cannot grow, and it will not rust when washed with a harsh cleaning chemical. By choosing this material, we are making sure our system lasts a long while and keeping consumer safety our number one priority. Thank you.